Hi, algebra class. Today we're going to go over our last topic in this unit. It's called factoring completely. This will actually be a 2-day lesson, but you can put today's date on for now. And this is the note packet that you'll need to go through the lesson with me. So I've included this flow chart. We have learned several factoring techniques. We have learned how to pull out the greatest common factor. We have used the product sum method. We have looked at difference of squares. We have looked at master product. So there's a lot going on here. If you follow the chart, it says that the first step you should always look at is, can you remove a greatest common factor from your polynomial or your trinomial? And if you can, you should remove that. And then you want to look at what's left over. So do you have two terms left over? Is it a difference of squares? If it is, you need to factor it further. If it's not a difference, so you don't see minus, it's likely that you can't go any further. So the flow chart says nope, and you can't factor it, and you stop. If you remove the greatest common factor and there's 3 terms left, is it a perfect square trinomial? So you might see something like this. Even though there's 3 terms here, the front term and the last term are both perfect squares. What this tells me then is I can factor this again. This time they'll be identical factors with the same sign. If it's not a perfect square trinomial, is there some kind of numerical value in front of your trinomial greater than 1? If there is, this is where we need to use our master product. So here, A is 2. So they're calling it decomposition here, but we use the master product rule, and that's exactly what they're doing. If the factor in front of the first term is 1, we're going to use the product sum method. So it would multiply to negative 12, add up to 1. We should not see 4 terms left, but if we do, this is the process that you will follow. But this is a little bit more advanced than we are. So let's try our first example. The first step is to determine if we can remove a greatest common factor for all 3 terms. Remember, you can pause the video if you want to try any of these on your own. So when I look at the 3 terms, I am not able to come up with a number or a variable that's common to all 3 pieces. So there is no greatest common factor. But what I do notice is that the value of A is greater than 1. So that tells me I need to use the master product method. So I'm going to make a list of factors from my master product. So I'm multiplying the A term and the C term. Notice it's negative. That means when I list my factors, I'm going to have 1 positive and 1 negative factor. If you want to pause the video before I bring up the factors, you're welcome to do that. Because our master product is so large, we have a large number of possible factors. We want to select the set that will add up to positive 28. And I've identified negative 8 and positive 36. So what I'm going to do is rewrite my trinomial as a sum of 4 terms. And I'm going to remove 28b and replace it with positive 36b and negative 8b. And if you'll remember from past lessons, we're going to split it into a front half and a back half. So in the front half, we want to see what's common to both pieces. And I'm going to say that that common factor is 9b. In the back, looks like the common factor is 8, but it could also be negative 8. We just won't know until we get to that portion. All right, so when I remove 9b, I'm left with b plus 4. I want there to be a matching factor in the back, so that tells me when I pull out the GCF, it has to be negative 8. And then I'm going to write my final answer as 2 binomials, and this problem is factored completely. Our second example. Is there a greatest common factor? When I look at that, I don't see a common factor between either of the terms. Since the value of A is 1, we're not able to use master product. But what I notice here is the front term and the last term, those are both perfect squares. So since both terms are perfect squares, I'm going to separate this into two identical binomials. They will have different signs, one positive, one negative. Remember, we're separating x to the fourth into two identical terms of x squared and 16 into two identical terms of 4. What you need to look at is what's left over. This first term, x squared minus 4, is still a difference of perfect squares. So this first term needs to be broken down further. The second term, though, is not a difference. So this one will remain as it is. So in my final answer, I have 3 factors, and now this problem is factored completely. In number 3, is there a greatest common factor? When I look at both terms, I notice they both have a b in common. So I'm going to remove that from both terms. And I'm going to keep the greatest common factor in front, but I have a leftover term of y squared minus 4. At this point, I can see that a is 1. But I also notice that y squared and 4 are perfect squares. So I'm going to use the difference of perfect squares method. I'm going to separate that quantity into two identical terms. Again, they both have different signs, one positive, one negative. And there's my final answer, and this one is now completely factored. In number 4, I have a trinomial. Is there a greatest common factor that can be removed? They all have a factor of 3 in common, so we're going to remove the 3 and then divide each term and see what's left. Now, when I look at this, the value of a is equal to 1. So we're not going to use master product. We're going to use our product sum method. So I'm looking for factors that will multiply to -8 and then add to -2. If you want to pause and make a list of factors, you can do that. I know that my factors have one positive and one negative, so I've assigned the negative to the smaller value. But as I examine this, the second group will add up to +2. I need it to add up to -2, so that tells me that my signs are incorrect. So I'm going to select +2 and -4. And then my final answer includes the original GCF and then the binomials x plus 2 and x minus 4. And this problem is now completely factored. For our final problem today, I'm going to ask you to jump to number 6 in the note packet. And our first step, is there a greatest common factor? I'm going to pull out both a number and a letter. So my greatest common factor is 3b. We're going to go through and divide every term in the trinomial by 3b. And that leaves behind a trinomial. Now I'm looking at this and I see that the value of a is greater than 1, but 9 is a perfect square, and so is 1. So this will be a little bit new for us. We are going to use a difference of perfect squares method, but there's not really a difference there because the 1 is positive. So that tells me that the signs are the same when I break it apart. So in my final answer, there's the original greatest common factor. We will split 9a squared into 3a and 3a. And to get +1, I'm going to need -1 and -1 in both quantities. But if you check through distribution, you'll see that you achieve a -6a in the middle. And then ultimately, this problem is factored completely. This is homework number 99. Here's number 1. You can see it's x squared minus 17x plus 60. This is going to be a mix of all the factoring techniques to see if you have a good handle on this. If you have questions while you're going through the notes or the homework, you can call me, you can text me, or you can send me an email. Also, every time you complete a homework assignment, I would like you to forward that to me so that I can get it into the grade book. Even if you're a little bit behind, just start sending what you have. Have a great day.